Hello and a warm welcome to this webinar, Assuring Carrier-Grade Services in Network Function Virtualization. My name is Isabelle Morency and I'll be the moderator for today's session. I'm currently Vice President of Engineering and Standards at Verix Technologies and greatly involved at the MEF Forum in the areas of service management and lifecycle service orchestration. With the telecommunications operators always looking at ways and means to accelerate the deployment of new services in support of their revenue growth plans, the concept of Network Function Virtualization, or NFV, has emerged. NFV decouples network functions from their purpose-built hardware devices and runs them as software in either virtualized or bare metal commodity servers. NFV is significantly helping forward-looking operators and service providers to dynamically design, deploy, and manage new services, allowing them to get an edge over their competition. NFV also provides a number of benefits, such as reducing the need for expensive purpose-built hardware appliances, supporting pay-as-you-go on-demand service models, eliminating unnecessary over-provisioning, simplifying rollout and management of network services, and scaling services up or down based on the subscriber's needs. Reaping so many benefits from the NFV deployment, it's also important to look at what may have been given up to get there. The first few areas that may come up to our minds are performance, reliability, stability, and scalability. Are we compromising on these while transitioning to NFV? So in the next hour, we'll be looking at the indicators of these areas, one by one, and see if any of those have been given up at the expense of the new benefits of NFV. As we all know, there's still some skepticism about network function virtualization. And that's the reason why so many proof-of-concept projects are underway to evaluate the various aspects of NFV and try answering questions like, will it provide the same performance? Will it scale based on the subscriber's requirements? Will it provide the 5 nines reliability? And what about stability? Now, wouldn't it be good to have mechanisms to qualitatively evaluate NFV and to confidently transition to an NFV architecture? In this webinar, we'll examine the changes in network operator landscape due to NFV, the various challenges for delivering carrier-grade services using it, the key performance indicators or KPIs that can assure carrier-grade services and their significance. And finally, we'll present some recommendations on how these KPIs can be measured. Now, in terms of logistics, we'll have 2 poll questions during the course of the webinar and a Q&A session at the end. I will allow you around 30 seconds to respond to each one of the poll questions. And at any time during the course of the webinar, please feel free to type in your question and we'll address them during the Q&A session at the end. Let me now introduce our presenters. Our first presenter is Mr. Anton Basil. Anton is Vice President of Technology and R&D at Verix Technology and also co-chair of the Analytics Working Group at the Open Cloud Connect. Welcome, Anton.
Hello, everyone.
Our second presenter is Mr. Bhuvan Vangenathan. Bhuvan is Senior Manager of Technology Innovation at Verix Technologies and author of the IETF draft on benchmarking SDN controller performance. Welcome, Bhuvan.
Hello, everyone. I'm happy to be part of this webinar today.
So before handing over to my colleagues, let me briefly introduce Verix to you. Founded in 2002, Verix is a provider of test and measurement solutions for the communications industry. Over the last 13 years, we've been developing and offering automated test solutions for the verification of broadband access, carrier Ethernet, data center, enterprise, and industrial networks. More lately, we've been focusing our efforts on network monitoring, visibility, and analytics solutions for SDN, NFV, cloud, and Internet of Things deployments, for which we were honored the 2015 Internet Telephony NFV Pioneer Award and selected amongst the 2015 Red Herring Top 100 in Asia. As a key contributor to the MEF, the Open Cloud Connect, and the IETF, VERIC is part of the industry leaders shaping the way to next-generation network benchmarking, management, visibility, and analytics. So over to you, Anton.
Thank you, Isabel. I'm glad to be presenting in this webinar today. We will now understand the change in service provider landscape due to transition to NFV architecture. With the trend in telecom industry to move towards NFV, the service providers are considering moving away from purpose-built hardware towards software-only solution that run on industry commodity servers, switches, and storage devices. By adopting this, service providers are expecting to reduce capital expenditure, operational expenditure, and time to introduce new services. With this software-driven approach, service providers can achieve much higher degree of automation, thereby simplifying the operational processes. NFV brings in proven cloud computing and IT technologies whose attributes are low cost and agility to service provider arena. But the flip side of it is this is not enough to meet the strict requirements of service provider. Typically, service provider application mandates service delivery at real time with high availability. Hence, we need to integrate the best attributes of cloud and IT, which is agility and low cost, with service provider requirement, which is real-time performance and high availability. This will massively change the networking landscape of service provider network, that is, transformation from physical to combination of physical and virtual components, fixed network to flexible cloud-based network. This landscape change will also pave way for introducing innovative service quickly as well as scaling of offered service based on the end user need. Let us now look at the change in the service delivery. This is especially in terms of service fulfillment and service assurance. In a traditional network, service fulfillment involves feasibility study, network provisioning, and service activation. Whereas in NFV scenario, it involves feasibility study, VNF forwarding graph identification as well as creation, and network provisioning, which also includes VNF provisioning. From the service provider standpoint, network and physical device monitoring are performed in traditional network, whereas in NFV, network, VNFs, and physical devices, if any, are monitored for service degradation. In traditional network, the performance is measured once the service is activated and operational, whereas in NFV, the performance is measured right from the time service is created and continued as long as service is active. The reason for doing such an elaborate performance measurement is that NFV allows dynamic service creation with auto scale up and scale down capability. Hence, the number of metrics to be measured will be more in NFV compared to traditional network. Now that we have an understanding of change in service provider landscape, let's move ahead to discuss the challenges in delivering carrier grade service with NFV based network deployments. These challenges will have to be overcome to assure carrier grade performance, which in turn will provide confidence to the service providers to transition to NFV based network. Before we move forward to discuss the challenges, we would like to take some feedback from the audience. Isabel, over to you.
Thank you, Anton. We'll now have our first poll question about the transition to NFV. So the question is, what do you think is the most important roadblock to NFV transition? You have doubts about the NFV real-time performance? You have security concerns about NFV deployment? You think that the existing management framework needs to be improved? Or in your opinion, commodity servers still need to mature to support NFV? Now please go ahead and choose one of the displayed options. So Anton, as the audience poll is in progress, what do you think is the bottleneck in NFV adoption?
I look forward to hearing from the audience out there, but I feel there could be varying reasons based on how far the organization has come in assessing and implementing NFV-based network. But my sense is that once we have hard numbers in terms of NFV performance, there would be more enthusiasm to shift towards the NFV paradigm.
Thank you, Anton, for your opinion. Will you now continue with your presentation, please?
Now, I will cover the challenges to deliver carrier-grade service with NFV architecture. The first and the foremost of the challenge is to provide same, reliable and deterministic performance as traditional network based on purpose-built hardware devices. As we know, any purpose-built device with real-time operating system will definitely provide highly reliable and deterministic performance. Looking at NFV, where the network functions are made to run as software on commodity server, there is always a doubt if it can deliver the same performance as purpose-built hardware device. To verify that, it will be good to measure service performance indicator and see if this is comparable with the performance measured on purpose-built devices based network. This will provide confidence to service provider to transit to NFV-based network. Next challenge is related to deployment of VNF. How quickly VNFs can be deployed? How much VNFs can scale? How reliable is VNF deployment? These challenges arises due to virtualization of network functions. Since network functions run as software entity on commodity hardware, its reliability, its ability to scale on commodity hardware, and speed at which it is deployed seems to be one of the challenge in NFV deployments. The factors contributing to this challenge is the infrastructure on which the network functions are running. Even though commodity hardware vendor claims that this challenge has been overcome with high performance computing hardware, the doubt about the performance of the software based on network function still lingers in everyone's mind. How do we provide the confidence to those who doubt the performance of virtual function? The way to go about is to define the performance indicators for network functions running on commodity hardware, measure those indicators and compare those with the expected performance. If it is comparable with expected performance consistently, then it will boost up the confidence for those who plan to migrate or in the process of migrating to NFV-based network. Finally, let's look at the challenge due to orchestration of network functions. We know that one of the benefits of NFV is to provide on-demand, pay-as-you-go service model and scaling up and scaling down of service based on the end-user requirement. It is also important to understand that orchestration plays a key role in providing on-demand service offering. Hence, the speed at which the required network functions are orchestrated and reliability of such orchestration will impact the end-user experience. How do we address this challenge? benchmark those orchestration operations which lead to dynamic VNF placements and provisioning. The next step now is to define those benchmarking metrics. Measure them, observe it if it provides acceptable performance. With this metric, we will be able to provide good insight about orchestration performance to the service provider so that they can make a decision on whether to transit to NFV or not. With a good understanding of challenges involved in delivering carrier-grade service, the next step will be to make sure that these challenges are overcome. First, the indicators that can guarantee that the challenges have been successfully overcome need to be identified. Those identified key performance indicators should be measured. Compare with the expected performance. Observing acceptable performance from key performance indicator will assure that challenges have been overcome. Key performance indicators along with the associated metric which assures challenge have been overcome will be discussed next. Let's look at the key performance indicator classified according to the challenges. First, we look at service benchmarking KPI, which will address the first challenge, that is NFV performance on par with hardware-based network. This KPI benchmarks the service for carrier-grade performance when the service is operational. It will provide information on NFV-based service performance and lot of insight into how it compares with the service performance of traditional purpose-built hardware-based network. Even though the metric measured are same as traditional network, the methodology used to measure will differ for NFV-based network deployments. The metrics that are measured for service benchmarking are well known, like packet delay variation, desired throughput, packet loss ratio, and service availability. We know that these are the same metrics measured on traditional hardware-based network, but the measurement point where the performance is measured will differ for NFV-based deployments. Next, we look at the KPI that benchmarks the VNF deployment. This metric comes into play due to virtualization of network functions. Okay, now what do we measure here? We measure the VNF deployments in terms of speed, scalability, reliability, and availability. These metrics were not relevant in traditional network as the network functions are always available and utilized as and when required. But in NFV, the required network functions, that is VNF, are deployed only when it is required for a service. Hence, the VNF deployment benchmarking becomes vital and will be contributing factor to carrier grade performance. The metrics that are covered under VNF deployment KPI are VNF deployment latency. What it is? This metric measures the time taken to onboard a VNF, provision it, create a VNF forwarding graph with onboarded VNF. This will impact service latency, which will in turn influence the quality of service experienced by end user. Also note that if this latency exceeds maximum acceptable latency, then the state is considered as VNF reliability impairment. Now we look at VNF deployment reliability. This metric characterizes the reliability of VNF forwarding graph creation. It is a measure of number of successful creations of VNF forwarding graph within maximum acceptable latency. Even though this will not impact service latency, it will indirectly impact the quality of service experienced by end user. Third metric is VNF scale factor. This metric measures the ability of VNF to scale up or down according to varying network conditions. Typically, service scaling up or scaling down will happen due to requests from the end user. It will impact the service delivery, especially in addressing the varying needs of end user. Finally, we look at VNF outage. This metric measures the unavailability of VNF beyond maximum acceptable transient time. It is considered as the service disruption and will impact the quality of service offered to the end user. Lastly, we look at the VNF orchestration benchmarking, which will track the dynamic changes to the service offered to end user. One of the benefits of NFV is to provide dynamic service based on end user needs. Hence, this KPI becomes relevant for offering carrier grade services. Within this KPI, we look at a new set of metrics that needs to be measured and benchmarked for VNF orchestration capability. We need to be cognizant of the idea that orchestration is a key element in providing on-demand, pay-as-you-go service offering and service scale-up and scale-down. The metrics covered under VNF orchestration benchmarking KPIs are: first, VNF reprovisioning latency. This provides a measure of time taken to dynamically chain a VNF to existing VNF forwarding graph based on user request. It will impact the service latency, which will in turn impact the quality of service experienced by the end user. Next, we look at VNF reprovisioning reliability. This metric characterizes the reliability of VNF forwarding graph change. It may be due to user request or network requirement. It is a measure of number of successful change to VNF forwarding graph within maximum acceptable latency. Even though this will not impact service latency, it will indirectly impact the quality of service experienced by end user. Now we have fair understanding of the KPIs and associated metric to be measured. The next step is to discuss how these metrics can be measured. The method adapted to measure will differ based on the KPIs that are being benchmarked. It is also important to specify the measurement points in line with HC NFV Mano architecture, and that will provide the basis for positioning the measurement module in NFV Mano architecture. The procedure to measure service benchmarking, VNF deployment benchmarking, and VNF orchestration benchmarking, and positioning of modules in NFV Mano architecture will be discussed next. Before we present the methodologies for benchmarking, we will have the second audience poll. Isabel, over to you.
Thank you, Anton. So let's now proceed with our second poll question. Which network functions are you most likely to virtualize in your NFV deployment? VCPE, VEPC, vRouter, or VBNG? You can pick more than one options here. Thank you everyone for your opinion again. So now over to you, Bhuvan.
Thank you, Isabel. Now I'm going to present the recommendations on how various benchmarking metrics that were discussed by Anton can be measured. We will start with the recommendations for service benchmarking. As we already discussed, the service benchmarking metrics for NFV based deployment is nothing new as compared to hardware device based network deployment. The methodology and the measurement points will vary for the NFV based deployments as there is a change in the placement and positioning of virtual network functions in the network. Before getting into the methodology and measurement points, it will be good to look at various NFV deployments that are being adopted by service providers. One approach is distributed NFV and the other one is centralized NFV approach. In the distributed NFV, some of the virtual network functions are deployed in the customer premise and some of them in the carrier's POP data centers. Whereas in the centralized NFV, all the virtual network functions are deployed in the carrier's POP data centers. In both the deployments, we should have ability to benchmark layer 2 or layer 3 services with well-known service metrics so that the service performance can be assessed and compared against the metrics from the traditional hardware-based deployments. Further, we should also pay attention that the measurement points are in line with HC NFV Mano architecture. Secondly, in addition to providing the values for the measured service metrics, the methodology should also provide additional information to troubleshoot and correct service degradations. Now, let's look at how do we measure the service benchmarking metrics in distributed NFV deployment. Assuming that a EPL or IP-based service is created between two customer locations over a distributed NFV architecture, the key measurement points needs to be considered are the service endpoints at the customer locations and at the NFV POP data centers. Also, it is recommended to have the measurement modules at the service endpoints in customer locations as well as in the NFV POP data centers to do the end-to-end service performance measurement. With the information gathered from these measurement modules, the metrics for end-to-end service performance can be obtained. By performing the suggested measurements at regular intervals will provide additional information to identify and troubleshoot the service performance degradation apart from service benchmarking. Now, we'll look at how to measure the service benchmarking metrics in the centralized NFV deployment. By taking the same example of EPL or IP service created between two customer locations over the centralized NFV architecture, the key measurement points that needs to be considered here are the service endpoints at the customer locations and at the NFV POP data centers. In this model, one approach is to have the measurement modules at the NFV POP data centers and perform the measurement on each direction to obtain the metrics for end-to-end service performance. This measurement module should be able to measure the end-to-end performance using standard mechanisms. Further, it should be able to provide the required information for troubleshooting and correcting the service degradations. Hope the service benchmarking methodology discussed above for both the NFV deployment models would have given a fair amount of understanding about the methodology that can be used for service benchmarking in the NFV architecture. With this understanding, let's go ahead with the methodology for VNF deployment benchmarking. With NFV, the network functions are virtualized and runs as software components on commodity hardware servers. So it is important to measure the time it takes to onboard the network functions, provision them, and make them available for the service fulfillment. The numbers in the diagram shows the flow of how the provisioning happens in the HC NFV Mano architecture. This benchmarking measurement should also consider measuring the reliability, scalability, and availability aspects of the network functions. The measurement point in this case will be the orchestrator in the HC NFV Mano architecture. The measurement module must coexist along with orchestrator to track successful and unsuccessful deployment of VNF forwarding graph and the VNF's availability. the measurement module should also be able to provide the required benchmarking metrics for VNF deployment. This is one of the key aspects for the service fulfillment. Further, the scaling of network functions can also be measured by emulating the service endpoints and measure the ability to handle the number of sessions as well as the support for automatic scaling up and scaling down of VNF VMs based on the service needs. Secondly, as the measurement module is coexisting along with the orchestrator, it should be able to provide the required information for troubleshooting issues with the VNF deployment. Now, with the understanding of the methodology for benchmarking the VNF deployment, let us proceed with the methodology for benchmarking VNF orchestration. One of the key benefits of NFV is offering on-demand services. VNF orchestration plays a key role in providing such a dynamic service. Hence, benchmarking the VNF orchestrator's performance becomes essential. The aspects that needs to be considered here are the time it takes to service chain a network function to an existing VNF forwarding graph and how reliable are those operations. The measurement point in this case will be the NFV orchestrator in HCNFV Mano architecture. The measurement module must coexist along with orchestrator to track successful and unsuccessful VNF forwarding graph updation. The measurement module will then be able to provide the required benchmarking metrics for VNF orchestration, which is key for offering on-demand and pay-as-you-go services. Also, as the measurement module is coexisting along with the orchestrator, it should be able to provide the required information for troubleshooting issues with the VNF deployment. Now, having understood the methodology for performing the service benchmarking, VNF deployment benchmarking and VNF orchestration benchmarking, let's have a quick overview about Verix offerings for NFV. Verix offers a range of solutions for testing, benchmarking and real-time monitoring and diagnosis of network services and elements in carrier Ethernet, NFV, cloud and SDN deployments. Further, for NFV environments, Verix utilizes its VNF test probes and virtual taps solution to enable service providers to benchmark and monitor their VNFs and NFV based services for delivering carrier grade services over NFV deployment. Also, Verix NFV solution helps VNF providers and system integrators in performance benchmarking and diagnostics of VNFs and its orchestration platform in lab networks. Over to you, Isabel.
Thank you, Bhuvan, for your good overview of the different methodologies and the Verix tools to benchmark NFV performance. I'm hoping that the audience, representing a cross-section of equipment vendors, enterprises, and service providers, have found the presentation helpful and educational from the viewpoint of assessing and benchmarking NFV components and networks. Now we have received several questions from the audience already. And by the way, I would request those of you who have any more questions to use the box on the top right side of your screen to type them in. So here's the first question. When you talked about the service provider landscape change, you mentioned that the NFV deployments have a combination of physical and virtual entities. How do you measure performance for such a combined network? Anton, would you take this question, please?
Yeah, that's a good question. When it comes to service performance, it will be end-to-end performance, which includes both physical and virtual component. Finally, what matters is how do we relate these performance metrics to the customer SLA. This problem arises only when you see physical and virtual entity in isolation. That's why the methodology we have recommended abstracts the underlying entity and measures the end-to-end performance.
Thank you, Anton. Now we have a second question here. There are many tools already available for benchmarking NFV deployments. How would Verix tool compare with them? Anton, please.
Tools that are available in the market support benchmarking of individual VNF or group of VNF. In some cases, the infrastructure that hosts the VNF, whereas Verix solution is different from those and measures the end-to-end performance, not a VNF or the infrastructure. It covers both physical entity as well as VNFs that are chained together to offer a service to end user. Just to give a gist of what Verix benchmarking tool provides, it gives end-to-end service benchmarking, VNF graph deployment benchmarking, VNF orchestration benchmarking. Apart from that, it also provides additional information to troubleshoot the performance degradation. That gives how Verix benchmarking tool compares with the others that are available in the market.
Thank you, Anton. Here's a third question. Are the metrics covered in your presentation aligned with the metrics defined by any standards body?
Standard bodies like HC have already come out with service quality metrics. The metrics defined by HC measures the performance for virtual machines, virtual network, and technology component offered as a service. We have taken lead from those metrics to define metrics at slightly higher level, which inherently encompasses the metrics defined by HC. We are of the view that metrics we measure should relate to service and service impacting event. End of it, we would like to have a metric that will assure a carrier grade performance with NFV architecture.
Thank you, Anton. So let's take one more question. Does the methodology recommended here only work with the Manu architecture? What if I want to do these measurements on a proprietary or a contemporary architecture?
That's again a good question. The methodology we are recommending is independent of the underlying architecture. Right now, we have mapped it to Manu architecture, which is widely being used for proof of concepts. We also observe that there are some discussions going on regarding the alternate architecture. In either case, the methodology what we recommend is agnostic to the underlying architecture, and we can always map the measuring points to any NFV architecture, even if it is proprietary to any customer.
Thank you again, Anton, and also Bhuvan. So I would also like to thank everyone in the audience for taking the time to join us today. And I hope our webinar was helpful and educational and brought some clarity around the main challenges faced during the NFV transition, the different KPIs for NFV deployments, and the methodologies for measuring those KPIs. So please feel free to get in touch with us, Anton or Bhuvan, for any further information on network function virtualization. Thank you and have a great day.